Hello all, welcome to KSM 3413 Statistics 1. In this video, I'm going to share about central tendency. So what is central tendency? In the previous video on frequency distribution, we learned the purpose of statistics, which is the first purpose of statistic is to organize information. So what we did in frequency was when you get a pool of scores or pool of information, we organize them into a comprehensible table or into a comprehensible form so that it's easy to understand or easy to make interpretations. So we cannot just stop at understanding about the data by just having a frequency. Okay, if you have a long list of variables, long list of data, you cannot just have a frequency to describe every score. So what we are moving on to in this video is how can you actually summarize the information from the information that we have organized previously. So once we organize, we would like to try to get a single value that can represent the entire pool of information. So sounds very easy, right? Yes, it is very easy, and this is doable through central tendency. Central tendency is a way that we use to describe the distribution of scores. It's an pool of information that we organize and we summarize into single scores that can help us to understand about the distribution of scores. It is actually the summary of the score distribution. We try to synthesize, we try to get what is the main idea or main points, or when you summarize something, you just want to get the gist of it. So same thing with the distribution of scores, distribution of data, we want to get the representative of all this information. And this can be measured in three ways. So when you're summarizing a pool of information, you can get three different ways that you can do it and three different information that you can get. One is the mode. Mode is actually the data value that with the highest frequency. What is the value or what is the score that appear the most in your data set? Okay, for example, in the table above, if you notice the frequency, if you check the frequency, number 7 appears the most in the table. That means number 7 appears 5 times. It appears the most highest time in the data set compared to other values. So that is one information that we can get. Second is we can also find the median. Median is the score that divides the distribution exactly into equal halves. Meaning what is the value that divides the entire pool of information into equal half. That means there are equal number of scores below this particular median value and there are equal scores above this particular median value. And finally is the mean. Mean is actually the arithmetic average. We always use this average. What is the average height of a person in your class? That means we take everybody's height and then we take the average out of it. So basically average is the mean is the term that we use in statistics to represent average. So what is mode and median in specific? So let's go through how do you actually find mode? What is actually mode is all about. So mode, as we mentioned, is the score or value that has the highest frequency. For example, if you have a data or information with the score value of 2, 4, 5, 3, 6, 4, 6, 4, 7. So what you need to do firstly is, in order to identify the mode, you have to arrange them in the ascending order. That means from the smallest to the largest value. So from the value above, what I did is I rearranged it. So 2, 3, 4, 4, 4, 5, 6, 6, 7. So from here, the next step is to determine the score or value that appears frequently in your list. So what is the value that appears the most in your list? If you notice, 6 appears twice, number 4 appears 3 times. So which one is the most frequently appearing appearing value? Yes, it is 4. So 4 is the mode for this distribution. 4 is the most frequently appearing value in your data set. Next, median. What is median? Median is the score or value that divides the distribution into equal half. So again, let's use the same example as above. So you have a value of 2, 4, 5, 3, 6, 4, 6, 4, 7. So from here, what you need to do first is arrange it in ascending order. So arrange them from smallest to the largest value. So I rearrange it 2, 3, 4, 4, 4, 5, 6, 6, 7. So what you need to do next is determine the middle location that has equal score above and below that particular location. So if you notice, you have how many scores? You have um, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 scores. So if I count from here 1, 2, 3, 4, 4 and then another 4 here. So this location, the middle point actually has 4 numbers below and 4 numbers above this particular location. So this is the value that splits the entire distribution of scores into equal halves. So basically number 4 is my median, because below number 4 I have 4 values. Above this location, above median 4, I have 4 values. So this 4 is actually the middle point that breaks my distribution into equal halves. So for even numbers, okay, above was odd numbers. So when you have even numbers, how do you do that? So let's look at the even numbers. You have how many values? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 scores. So how do you find the median for this even number? So when you found there is, okay, that this location, the highlighted 4 and 5 is the location where you will have equal distribution above and also below. So if you notice, there is, if you have this location 4 and 5 location, if you this two values location, you notice there is 3 scores below and 3 scores above. So these 4 and 5 is actually the location. But remember, when you summarize, there's only one value. You cannot have two values. So what you can do is, for median, you take both the scores 4 and 5, divide by 2 and you get 4.5. So the 4.5 is your median. So let's talk about what is mean is all about. So mean, as we said, is just the arithmetic average. So how do you get the average? We add all the scores in the distribution and divide the total scores that you have in the distribution. Okay, so it's as simple as we usually do. And when you are using mean in the statistics, okay, sometimes you have to remember the symbol that we use. So when you're referring to population, okay, when you're referring to the population, you use the symbol of mu. So if you notice, we use the Greek letters. And when you are using a sample, we usually use capital M or X bar to represent the mean. So what is the formula? So X bar or mu or M is the sum of X, the sum of total scores that we use, divided by the total scores in the distribution, number of scores that we have in it. So what is actually mean is all about? Mean is actually the amount each individual get if the total score is divided equally. So let's say that you have 6 scores and the total is 18. So the mean will be 3, right? When you have total of all the scores is 18 and you have 6 scores or 6 people or 6 individuals in it, so you will get an average of 3. So what does this 3 means? Every individual will get 3 points equally. So the mean is like trying to say that if you divide them into divide them and you get the equal values for each individual in the data. Secondly, mean is a balance point for distribution, meaning when you add the difference between scores below and above the mean, it will be equivalent. Okay, let's say that you have a score of 1, 2, 3, 4 and 5. So what will be the mean of these scores? It will be 3. How did we get 3? So 1 plus 2 plus 3 plus 4 plus 5, you get 15, and you get 5 scores in it. So 15 divided by 5, you get 3. So look at the highlighted ones below. Okay, when I have made it bigger on the score. So you have score 1, 2, 3, 4 and 5. Okay, so the mean is 3. So what is the distance from the score, the difference of the scores from 1 to 2 and 1 to 3? Okay, so the difference of from this scores. Okay, 1 and 2 is below the mean, 4 and 5 is above the mean. Okay, so what I'm trying to show here is when you look at the difference of the scores below and the difference above the mean will be equivalent to 3. Okay, let's see. So 1 and 2, the difference is 1. 1 and 3, the difference is 2. Okay, so when you add 1 and 2, you will get 3. So what is the difference between the mean and 4? Is 1. Mean and 5 is 2. So 1 and 2, when you add it, you will get 3. So that is what we are trying to say here. 3 is like a balance point. 3 is the mean. Mean is the balance point. So the difference between the scores below and above will be the same. So the added difference of the scores below mean and the added difference above mean will be equivalent. Okay, so let's look at the characteristics of mean. The first thing is when you change a score, the mean will change. Example, you have a score of 8, 9, 7, 5 and 1 and the mean will be 6. How do you get 6? 8 plus 9 plus 7 plus 5 plus 1. Divide by 1, 2, 3, 4, 5. 5 scores, you get 6. So the following one, I have the same set of scores, but instead of 1, I change it to 8. So what happened to my mean? It changes. So it increases. So that is what I mean by on the second point by including or removing scores. When you add a value that is greater than the mean value will increase. As you notice above, I add a value of 8. 8 is actually bigger than the initial mean value. So what happened to the new mean value? It increases. So when you remove a value that is greater than the mean value will decrease. So this is actually what happens when you play around with the mean. Next is, interestingly, when you add, subtract, you do division or multiplication of a constant to each score will change the mean by the constant. So what do we mean by that? Let's say the original score that you have is 1, 2 and 3. Okay, so what will be the mean of it? 1 plus 2 plus 3. 6 divided by 3 will be 2. So this is the mean for this original data. So let's say that if I add 3 to every original score. So 1 plus 3, 4, 2 plus 3, 5, 3 plus 3, 6. So from original, I've added 3 for each of the scores. So what happened to my mean? 4 plus 5 plus 6 will be 15. 15 divided by 3, the mean will be 5. So this 5, if you notice, is actually the mean, the original mean plus 3 because we added 3. So 5 is actually the mean plus 3 because we added a constant value of 3, a same value 3 to every score. So you are just making it bigger. Okay. Same thing, if you subtract a value from every score, the mean from originally we had 2, we just have to subtract the constant value. So let's say minus 1, let's minus 1 from the original score. So 1 minus 1, 0, 2 minus 1, 1. 3 minus 1, you get 2. So what is the mean of these values? Mean of it is 1. 1 is actually the mean, the original mean, minus the value, constant value that we added or we subtracted was minus 1. So 2 minus 1, the mean will be 1. So what happens when you multiply? Same thing. So from the original scores, when you multiply by 2, a constant value, a value 2 for every score, it becomes 1 times 2, 2, 2 times 2, 4, 3 times 2, 6. So the mean will be 4. So if you have the mean of the original data and you multiply by 2, you get the new mean. So basically what I'm trying to say is here is you don't have to calculate the mean every time. If you're adding, subtracting, multiplying or dividing a constant value in your data, what you can do is you don't have to calculate them every time for the new mean. What you can do is with the original data's mean, you can add or subtract, divide or multiply with the constant that has been added. Okay, so lastly, if you have divide by 2, so 1 divided by 2, 0 0.5, 2 divided by 1 and 3 divided by 2 is 1.5. So the mean will be 2. So 2 divided by 2, you get 1. So hope it was clear, and for hands-on or there are more videos on to show how to calculate mean, mode and median